Today we are going to continue studying the chapter 3, which is energy. Today we will focus on mechanical energy, and we are going to study the potential energy and the kinetic energy. And just to review, energy, remember, is the ability to do some work, and one way we can measure the level of the energy level of something is to see how much work it can do. And always when work is done on something, on some object, then change in the energy level occur in that object. Then when the work is done on some object, then always there is change in its energy level. Then we are going to study today that the relation between energy and work. This is what we are going to do today. Then we study there are different forms of energy. We say there are mechanical energy, chemical energy, electromagnetic energy, nuclear energy, solar energy. And today we will focus on the mechanical energy. This is what we are going to define today. Let's start with the potential energy. And let's think what happens if the rod falls. What happens if the rod falls? Then if the rod falls on this small rod we had here, then the rod can do this big rock can do some work. Yes. For example, can break the small rock. Maybe the pieces of the small rod can fly away. Means the big rock, yes, if the big rock falls, then what is happening is able to do some work. If that rock is able to do some work, is because that big rod has some energy. That what kind of energy? And the energy, in this case, the energy of the big rod is the potential energy, is the energy due to the position. And because this rod, the position of this rod has some height, then this is why this rod has some potential energy. And if this rod has this potential energy, then that rod has the ability to do some work. There are different kinds of potential energy. For example, there are elastic potential energy. Is the energy when we are talking about the springs or the elastic things, then we are talking about the elastic potential energy. There are also chemical potential energy. Is the energy is developed during the bonds, in the bonds. But in this class, we will focus on the gravitational potential energy, which is the energy due to the gravitational attraction of the Earth of an object. And in this course, we are going to focus just in gravitational potential energy. And in general, we will be talking about in this course potential energy. When we say potential energy, we are talking about the gravitational potential energy. And let's try to find the equations which we can use to calculate the potential energy. Then what happens if we done some work on this object, if we lift this block, yes, if we lift this block, then what happens if we lift this block? We are doing some work on that object, yes, because we are working against of the gravity, and we move the object some distance. And in this particular case, because the distance is vertical, then yes, we can say distance equals to h. But remember, d and h both means some distance. Now, what happens if we move this object up? then we are increasing the potential energy. This is we discussed in the previous slide. Then the work was done on this object is increasing the potential energy of the block. Means when we are doing work on this block, we are giving some potential energy to this block. And this is why we had this equation here. Then let's now try to write this one using symbols. Then the work on the block is, we are using W2 to represent the work, and the potential energy, we use PE as potential energy. Let's now define work. Work is force multiplied by the distance, yes, equals to the potential energy. And what happened now? What is the force? Remember, we work against the gravity. Then this is why in this case, force equals to weight. Then the force, and I just write weight because I don't want you to confuse work with the weight. Then weight multiplied by distance, but distance in this case equals to h. And it's just we use another letter to identify is vertical distance. Then, but weight we know is mass times g. Then the potential energy, then we can calculate the potential energy of any object, of anything, just if we know the mass, if we multiply by the g value in this particular place, and the height. The height depend on the reference level. And we will discuss in the next slide about the reference level. And now we define the potential energy equals the mass of the object, the acceleration of gravity times the height. The height depends on some reference level. Now we know the equation we can use to calculate the potential energy. Then let's now try to define the units. The units, then we had mass, G, H. Then the units for mass in SI system will be kilograms. The units for acceleration of gravity in SI system will be meters per second squared. And for height, which is a distance, will be meters. And let's now see this, just this part. Let's focus on this part. Remember, when we define the force equals to mass times acceleration, the units for force, mass is kilograms, acceleration is meters per second squared. And we say this units has a special name, and this is Newton. Then this is the units for force, is Newton. Then this is why here we have newtons times meter. And we say when newtons times meters correspond to joules. Then one thing we can see is that work and energy have the same units. This is why when we are able to do work on something, we are changing the energy level, because work and energy, they are the same. They have the same kind of units. Yes, we can interchange work by energy. When we are solving problems that involve gravitational potential energy, we need to select a reference level. But the important thing is that you should keep this reference level through all the problem. Yes, you cannot change that reference level. For example, if we want to calculate the potential energy for this ball in different positions, then we can select this as the reference level. Then we need to keep this reference level through all the problem. And in this case, the potential energy will be the mass of the ball multiplied by acceleration of gravity times the high, yes, this H value. But in this case, what happened is, what will it, if this is the reference level, then what will be the potential energy in this position? And even if we don't know the mass, we know the potential energy equals to 0. The reason is the high, the H value equals to 0. And in this case, there is no high, this is why the potential energy equals to 0. In some cases, if you decide this is the reference level you are going to, you choose to, when you are going to solve the problem, then the potential energy also can be negative. Yes. Then these negative signs depend on the reference level. But in this course, we will select the reference level in which we can, in the way the potential energy will be always positive. But we can choose that reference level according to our convenience. Yes, then we can select any reference level. The important thing is keep this reference level through all the problem when you are working in the problem. Keep the same reference level. Then now let's try to solve the problem. This problem, and we want to calculate what is the potential energy of a 2,140 grams book that is on the bookshelf 2.0 meters above the floor. Then we want to calculate what is the potential energy for this book. Yes, we want to calculate what is the potential energy. And we can, because they give the information of 2 meters above the floor, then we want to choose this as the reference level. As this is the reference level. This is the high equals to 0. And now we know the potential energy. And we need this 3. Then mass equals to, in this particular case, is 2,040 grams. G value and the height equals to 2.0 meters. Now we need to check before to start calculating the potential energy. The next thing we want to check if the units are consistent, if they are in the same system. And in this case, these two units are in SI system, but this is in Gaussian system or CGS system. It's in grams, and we want in kilograms because this is the unit for mass in SI system is kilograms. Then we need to convert this into the kilograms. And let's do this one first. Grams. Then we know 1 kilograms equals to 1,000 grams. And let me write here. Then if we this cancel out, and then will be 2.14 kilograms. Here we have 3 significant digits, 3 significant digits. Then here we can write this one is 2.14 kilograms. Now we have everything in the same system of units. And now what we had to do is just calculate the potential energy. And the potential energy mass 2.14 kilograms times G 9.8 meters per second squared times the height will be 2.0 meters. The potential energy, if we multiply these numbers together, then we can we will get, let's see, we will get 41. And let me write the units in this way just to check. And this is what we had. Yes, this is. Then because we had two significant digits, yes, for high, then in this case two significant digits for. Then we want here two significant digits. Then this corresponds to kilograms meters per second squared. Remember, this corresponds to newtons. Yes, this is newtons. And then times meter. Newtons times meter is joules, as we expected, because this is the units for energy, joules. Remember, the units for energy and work are the same, joules. And this is the answer, is 42 joules. Yes, the energy of this, the potential energy of this book in this position correspond to 42 joules. Now we are going to solve one more problem that involves gravitational potential energy. In this case, we had a horizontal force of 10 pounds. Remember, 10 pounds correspond to 10 pounds force. Yes, because it's a force. And it's needed to push a bookcase 5 feet across the floor. Then we want to calculate how much work was done on the bookcase, and also what is the change of potential energy when we move from one point to another point, the bookcase. This is what we want to calculate. And let's try to get the information from the problem first. Then we had a bookcase, yes, and the force is applying on the bookcase is 10 pounds force. And then this was moving by 5 feet. The distance was 5 feet. And let's write here the information we know. Force equals to 10. Distance equals to 5 feet. And we know we can calculate the work if we multiply just the force multiplied by the distance. Then in this case, before to calculate the work, we need to check if we had consistent units, if the units are consistent. And in this case, force is in American system, distance is in American system, then no problem. Yes, we had both quantities in the English system. Then we don't need to do any conversion, then just we need to calculate the work in this case. Then force multiplied by the distance, then work 50 feet. Also, if you write, and I think this is the way it's in your book, then both are the same. Then don't worry for the order of, in this case, pounds for feet or feet pounds force is the same unit. And in this case, there is no special name for the units of work. Yes, it's just like that. Then this is the answer for the first part of the problem. A. Now we want to solve the B. And we want to know what is the change in gravitational potential energy in this case. And remember, we can calculate the gravitational potential energy, mass times G times height. And remember, to calculate the potential energy, we can select the reference level we want. Yes, the reference level that is most convenient. And in this case, we can select the level, the floor, and the level of the floor as the reference level, and this will be the 0 for us. Yes, this is the reference level. If we want to, always when we want to calculate the change in some quantity, remember change, we use this symbol to indicate change, small triangle, and always the change means the difference between some final and some initial value, some second value minus initial value. And we can select these 2 points. Yes, this is the first point, this is the second point. Then what is the potential energy in the first point? And what is the potential energy if the reference level is this one? We don't know the mass. We know the g value because it's the acceleration of gravity, but we know h, the height, equals to 0 in this point, as we know. Then doesn't matter what is the mass, the potential energy in this point will be 0. Why? Because h equals 0. We multiply any quantity by 0, we will get 0. And the same situation happened in the second point. So the change in potential energy is 0. Yes. Let me write like that. And there is no change in potential energy. Yes, there is no change in potential energy. Let's write here just like 0. And in this case, there is no change in potential energy because there is no change in height. Yes, and this is why if the height of the bookcase from the reference level did not change, so the potential energy doesn't change. Yes, this is why here the change in potential energy equals to 0. Let me write this one. Change in potential energy equals to 0. Now we are going to talk about the kinetic energy. And the kinetic energy is the energy of an object due of its motion. Yes, any object that is moving has kinetic energy. And let's try to think in this situation. Yes, when we are bowling the ball. Yes, then first what he's doing. First, he's applying some work on the ball. Yes, he's applying some force in some distance. Yes, this is applying some force on the ball, some distance. Then he's applying some work on the ball. Because of this work, remember, work and energy, we can interchange. This is why they had the same units, joules, in the SI system. Then when he does work on this ball, then this increases the kinetic energy of the ball. Yes, this increases the kinetic energy of the ball. Now, because the ball has some energy, then that ball is able to do some work. Yes, can, for example, crush the pins. Yes, then the work is converted into the kinetic energy, but the kinetic energy then can convert into some work. Yes, can do now. Because of the energy that the ball has, the ball is able to do some work. Then we can see what is the correlation between work and energy. Then the kinetic energy can increase in 2 different ways. One, if the mass increase, yes, more mass, more kinetic energy. Also, if the speed is increasing, then more speed, more kinetic energy. But however, the kinetic energy is direct proportional to the mass, but the velocity of the object has greater influence. This is why the kinetic energy is proportional to the square of its velocity. And the kinetic energy is direct proportional to the mass, and we can see here, yes, if we are doing the line test, but the kinetic energy is direct proportionally to the square of the velocity, not the velocity. And this is why the velocity has greater influence on the kinetic energy. Now let's check the ionics. Now we know this is the equation. Yeah, this is the equation we can use to calculate the kinetic energy. And let's see the ionics. We had, in this case, we had mass, which is kilograms. We had velocity squared, and I want to write here the ionics for velocity are meters per second, but the ionics for velocity, and I want you to take into account this one when you are doing the problems, is meter squared over second squared. And this is why we had this one here. Kilograms meter squared over second squared. We can rewrite this one. We can rewrite this one like meter second squared times meter. Yes, we can multiply and we can rewrite this like meter per second squared times meter. This is we are doing there. Yes, we can rewrite this one, this like this one. But we know kilograms meters per second squared correspond to newtons. Yes, this is the ionics for force, correspond to newtons. And then we have meter. And this part corresponds to newtons. Now, newtons times meter correspond to joules. And again, work and energy have the same ionics. This is why we can interchange work by kinetic energy. Yes, when we are doing work on some object, we are giving, for example, some kinetic energy. Yes, kinetic energy. And now let's try to solve this problem. Then we had, in this case, a 7 kilograms bowling ball is moving in a bowling line with a velocity of 5 meters per second. Then we want to know what is the kinetic energy of the ball. As we had here, this line, we had here the ball, and this ball is moving with velocity of 5.00 meters per second. Then we know the mass of this ball is 7.00 kilograms. Meters per second. If we want to calculate the kinetic energy, then the first thing we need to check, in this case I have the equation here, then we know the mass, we know the velocity, then no problem. Yes, we can calculate. Here we had 1/2, this is a constant value. The next thing we want to check before we start doing the calculation is to see if we had the same system of units. We had kilograms, we had meters per second, everything is in the SI system, then we don't have problem. Now we can calculate the kinetic energy. Then let's and kinetic energy and mass 7.00 kilograms. Here the velocity, and we need to square. Then don't forget you had to square the velocity. This is a common mistake. Then please don't forget to square the velocity. Then now I will solve the problem step by step. In this way you can see what happened with the ionics also. Then 5 times 5 will be 25, but we need 3 significant digits. Let me write still 2. And we need to square the number and the ionics. Yes, we need to square both. Then here you can just multiply 7 times 25 and divide by 2. Or if you want, you first multiply 7 times 25, yes, and then divide by 2. Is here the way you solve the problem. How you multiply is depend on you. And kilograms, meters. And we know this corresponds to joules. Yes, this is we just discussed the kilograms meter square per second square correspond to joules. Then now equals to 87.5 and 3 significant digits. We have 3. We don't count the significant digits of the constant. Then here we can just say this is joules. Then the kinetic energy of the ball is 87.5 joules. Now we want to, and we had one more problem in which we will apply the kinetic energy equation. Then we want first to calculate the kinetic energy of the 30 grams bullet that is traveling at 200 meters per second. And the second thing, we want to calculate what is the momentum of the bullet. Then let's see what is the kinetic energy of this bullet. And we had here a bullet, yes, that is, the mass of this bullet is 30 grams and the velocity is 200 meters per second. Then we know we can calculate the kinetic energy. We know the mass and we know the velocity. Then we know the mass, we know the velocity, then no problem. We have the information we need to calculate the kinetic energy. But one more thing we need to check before start doing calculation is to check if the units are consistent. And we need all the units in the same system of units. In this case, we had grams, and this is in Gaussian or CGS system. And we had meters per second, which correspond to SI system. Then they are not in the same system, so we need to do something. And what we can do is we can convert grams into the kilograms. Maybe it will be easier. Then let's do that first. 30 grams, and we know here we had 1 kilograms. 1,000 grams is the only way the units we don't want cancel out, and then we will have here 0.0 kilograms. And let me write this. Let me move a little. Let me write here. This equals to 0.030 kilograms. Now we had everything in the same system of units. And here you see we had 2 significant digits, 2 significant digits. We don't change the number of significant digits when we convert one from one unit to another unit. Then now we know everything is in the same system of units, and now what we have to do is just calculate the kinetic energy. Mass will be 0.0 times the velocity will be 200 meters per second, and we need to square. And the kinetic energy equals 2. And we need to square the velocity. And I will do this one step by step. And this will be 4 and 4 zeros here. And we need to square not only the number, also the units. And here you can do the math in the way you want. And here we have 1/2. And here will be, we can multiply these two. You just multiply by everything. You can multiply the numbers in the numerator and then divide by 2. Yes, here we had and here we have meter square second square. And finally the kinetic energy will be 600. And this we had here one significant digit. We had one significant digit here, and no problem. And we know this corresponds to joules. Kilograms meter square per second square correspond to joules. Then the kinetic energy of the bullet corresponds to 600 joules. Now let's calculate the momentum. Remember, momentum is just mass times velocity. Then the momentum of the ball will be the mass. And here we don't have problem with the units because we already convert everything, all the units in the same system, times the velocity. If we multiply this, we had one significant digit in case of the velocity, then we want one significant digit in the answer, and it's 6 kilograms meters per second. There is no special name for units of the momentum, just we write 6 kilograms meters per second. And this is all I had to discuss for today.